Question 9, May-June 2023, Paper 22. Radioactive emissions and safety. Part A, Part 1, Strongest ionising radiation. Ionising power measures how aggressively radiation rips electrons from atoms along its path. Here comes an alpha particle, a helium nucleus, charge +2, mass 4. Watch the dense trail of ion pairs. Alpha ionises most strongly over a short distance. Now beta, a fast electron, charge -1. Fewer ions appear along a longer track, moderate ionising power. Gamma is an electromagnetic wave with zero charge. Almost no ionization, it passes straight through. Alpha wins, the strongest ionising radiation in this comparison. 9 Part 1. Alpha particles produce the strongest ionising effect. Ionising power increases with nuclear charge and mass. Alpha has charge +2 and mass for you. It strips electrons most aggressively. For the exam, alpha gives the strongest ionization. Part A, Part 2, Deflection in a magnetic field. All three enter a uniform magnetic field directed into the page. Alpha is heavy and doubly positive, only a gentle curve. Beta is very light and negative. The magnetic force deflects it sharply. Gamma has no charge. It is not deflected at all. Beta suffers the greatest deflection. 9 Part 2. Beta particles are deflected the most by a magnetic field. They are high-speed electrons with charge -1. Being very light, the magnetic force gives a large radius of curvature. Alpha curves gently, gamma travels straight through. Exam answer: beta shows maximum deflection. Part B, the Geiger-Müller tube experiment. A radioactive source sits 10 centimeters from a GM tube connected to a counter. With no absorber, alpha is stopped by the air before reaching the tube. Beta and gamma both register. The counter reads 800 counts per minute. A 5 mm metal sheet is placed between source and tube. Beta is absorbed by the metal. Only gamma gets through, 200 counts per minute. 800 minus 200 equals 600. That was the beta contribution. 9b Part 1. The source emits beta particles and gamma radiation. Without metal, 800 counts per minute, beta plus gamma. With metal, 200 remain, gamma only. 600 beta counts were absorbed. 800 minus 200 equals 600. Source emits beta and gamma. 9b Part 2. Alpha particles are never detected in this setup. They are stopped by a few centimeters of air. They cannot cross 10 centimeters. The GM tube end cap would also stop any alpha that did arrive. Alpha is stopped by air in the tube cap. Do not confuse ionising power with penetrating power. Part C, Safe handling of a radioactive source. Never touch a source with bare hands. Use long tongs at arm's length. Place a lead shield between the source and anyone nearby. Limit exposure time. Handle only as long as the experiment requires. 9c. Use tongs and keep maximum distance from the source. Place an absorber or lead shield between source and observer. Limit exposure time by handling quickly and storing in a lead box. Distance, shielding, and time together keep you safe.